Hello everyone, this is Deburpita Sarkar. Today I will explain you the topic of pulse code modulation in this session. Now see, pulse code modulation, that is what we are using it to convert the analog signal into digital data. That is, if we will be having analog signal like voice signal, and that voice signal we will convert into digital data in terms of 1 and 0, like this. In that, first we will doing sampling to convert the given analog data into discrete analog signal. Means if we have one continuous analog signal, then by having the sampling we can convert that into discrete signals. Then after sampling we will do quantization, and this quantization is being done to convert the discrete signal into digital signal. And lastly we will do encoding, so the encoding will translate quantized sample into digital data. Now this is the block diagram of pulse code modulation. Now we can see that a high frequency analog signal that we have to pass through the low pass filter, and it then become a analog signal which contains continuous time and continuous value, and this input will be given to sampling, so we will having sampled input. Now this sampled input that have continuous value but discrete time, so we will be given it to quantizer, and it will quantize the sample data into quantized output that contains discrete time and discrete value. Here we can see. Then by having encoding, we will convert from digital signal to digital data, that is 1010, like this. So here move forward. Here we can see the sampling process in pulse code modulation. And by this, the analog signal is sampled after a time interval, that is Ts. So obviously we can say that the frequency is 1 by Ts, and there we can see the three types of sampling, that is ideal sampling that impulse each every instant of time. Then natural sampling, that is a pulse of short width and varying amplitude. And lastly flat top sampling, that is a pulse of short width and with fixed amplitude. Here is the diagrams we can see. Then move to the next slide. Here is the quantization process. So quantization is the process of rounding of the sample value to the nearest quantization level. Remember that number of quantization level is not predefined. If n is the number of bits used to represent the sample, then q is the number of quantization level, that is 2 to the power n. And here is the steps of quantization process. First calculate the step size s, here you can see, and then draw the midlines representing quantized level, and then finally assign the binary codes to each quantization level. So here we can see quantization process introduce a certain amount of error or distortion. Move to the next slide. This error known as quantization noise, and minimized by increasing the number of quantization level, but increasing number of quantization level increase number of bits to represent each sample, and hence increase bit rate of cost of transmission. Then we can see the advantages or and disadvantages of pulse code modulation. First, uniform transmission quality can be maintained by having a pulse code modulation, and compatibility of different classes of traffic in network can be assigned like, see, if you use text data, then will be digital. If you see video data, then it will digital. And in parallel with that, converting audio signal into digital, we can have compatibility in a same network. This is possible obviously due to pulse code modulation, and an integrated digital network is utilizing that facility of voice transmission into digital by also pulse code modulation. Then we can see here other two advantages, that is increased utilization of existing circuits, good performance over post transmission path, like this. And there are some few disadvantages as well. There we will be finding large bandwidth for transmission, and if you want to accurate with signal, in that case you need to have more number of levels, and if you increase number of levels, in that case there will be large bandwidth with this required for transmission. See, and the next disadvantages we can see. So here is the explanation of pulse code modulation, and thank you. Hope you are able to understand this explanation.